So I record these lectures, and you can refer to the recordings. They're posted on YouTube. So here in our class page, if you click on lecture videos, it'll take you to my channel on YouTube. And you may have to search, because I'm also putting videos for hydraulic engineering and hydrology. You may need to try and look for the most recent one, but you can, I think this plays in like chronological order, the ones. And so, you know, the newest lecture will be at the top of the list, or if you search, for instance, you can say ENGR 222 Class 7. If you knew that you needed to go over something from Class 7, then, you know, here's the fall, here's the year before that, and so on and so forth. So all the lectures will be available to you. So here's the announcement slide we're going to start with. I really encourage you to get a 3-ring binder for this course, because I'm going to be giving you a lot of materials. In addition to the syllabus that I've just handed out, each class meeting there's going to be a handout with the in-class exercise. And those in-class exercises are example problems. And I don't ever want you to get a homework and be clueless. That's a terrible feeling, and I remember it when I was a student. You know, there would be some boring lecture that really never went anywhere. Then you suddenly have a stack of problems that you had to solve, and you're thinking, I don't get the connection between all that stuff that got said in the class and what I'm supposed to solve on the paper. Does that happen to anybody here? A few of you. So I don't want that to be your experience in this class, and so what I do is I prepare those in-class exercises as kind of a transition into the homework. So if you were here and you worked through the in-class exercise, I think you're going to look at the homework assignment and be able to say, okay, this is exactly like the first example from in-class exercise 1. This one is exactly like the second example. The homeworks are kind of a mirror image, and sometimes an extension or maybe a little enhanced complexity. But the point is, if you have a binder, then you're going to be able to keep all of these handouts that I give you each week, and it'll be organized and ready for when you do solve the homework, when you prepare for the exam. So there's just going to be too many papers if you don't have a good way of organizing it. I've already mentioned the textbook. I'd encourage you to get that as quickly as you can. And of course, we don't have class next Monday because of Martin Luther King Jr. holiday. And the first homework assignment that you've got due will be on Friday the 24th. So the PDF of the assignment is available now. I won't hand out printed copies of that. That will only be available electronically. But you should upload your PDF of that assignment to MU Online before the due date, which is 12 p.m. on Friday, so before class. Cam Scanner is an app that you can get either on Android or on an iPhone. And what it does is allows you to take a picture and build a PDF. Has anybody here used Cam Scanner before? A few of you have, a few of you haven't. So what I'm going to do is just briefly I'm going to demonstrate how Cam Scanner works. It syncs with the cloud, although you don't have to access it through their web page. It's a good way just to show how it works. And so if you download and install the app, then you can also create an online account. All right, so let's say that here's our syllabus. If I wanted to create a PDF of the syllabus, some paper that I have, I'd go to the app, click on Cam Scanner, and then it's going to bring up what just looks like a camera, any camera icon down here at the bottom, and then I take a picture, and it's best if you use like a background that doesn't have a lot of clutter, because it can automatically detect the edges, and so make sure that it's well lit, like don't put a big shadow, and don't have the paper wrinkled so that it's going to be blurry. Make it flat and well lit. You just take a picture, and then what it does in the interface here, you probably can't see, is it identifies the edges of it, and it's going to automatically crop, and it's going to correct for what's called keystoning, which is, if I take a picture of something at an angle, it's going to be bigger at the bottom and narrower at the top. And so it corrects for that keystoning. And what I ask, this is really important, so I'm going to write it on the board. Scan to black and white. By default, it's going to give you a color PDF, but it's not as sharp as if you, down here at the bottom, scroll sideways and make it black and white. It'll be more clear. The text is easier to read. And so as soon as I click OK, I can pull up that document here in the cloud that I just made the PDF of. And here it is. It's the syllabus. I can download the file either as a JPEG or a PDF. Your homeworks are going to be as a PDF, so you'd click that and save it in a location where you're going to be able to find it later. You know, don't put it in some mystery location that you won't be able to find. And so what I usually do is just create like some sort of a temporary directory, and then maybe this is It's amazing how sharp it is. I mean, it really does a nice job making a clear image. I don't have a particularly good camera on this phone. It's a junky phone, but I mean, it's going to be good enough for the grader to see. You'll notice that even though I did kind of take it at an angle, it's corrected, and so it's more or less rectangular rather than being distorted at the edges. And because it's in black and white, the text is nice and sharp. So I suggest Cam Scanner, but however you want to make a PDF is fine with me. If you have like a flatbed scanner or some sort of a batch feed PDF generator, that's great too. Any questions about the announcements? Today we're going to be talking about interest rates and rates of return. On the schedule, you can see which textbook chapters correspond to the lectures. So right now we're in chapters 1 and chapters 4 of the book. So my suggestion is that after each lecture, skim through the book and find the same material that we talked about and look and see if they have a different example that maybe makes more sense to you than the way I explained it. Or if there's some sort of an illustration of a problem that helps you to crystallize it in your mind. So the syllabus will identify where in the book to review. All right, so I've kind of already hinted about what's the subject of this course. It's about money. I like money. Money is a tool, and you know, it can be used well, it can be used poorly. You can do good things or bad things with money, but it's important that you understand the tool, because it's a tool that every one of us is going to use. There isn't anybody who just barters. And especially if you're going into engineering, money is a tool that is used to complete projects. And so just like you have to learn how to do technical drawing, you have to learn about construction tools or the materials that go into a circuit board, or biomedical applications, you know, there's lots of tools there. You have to understand the tool of money because it's something we use to complete projects. Now, in this course, we're going to use different techniques to compare alternatives. That's a big part of what I want you to have, is the ability to be faced with a scenario where you're considering maybe an option A that is a little steamroller for compacting asphalt, or option B is a big one. And so, I mean, maybe it won't be a steamroller, but at some point, whether you're comparing servers or a lathe options, you're going to have an option A and an option B, and the question is, which one should we buy? You know, one of them is cheaper, the other one is more capable, and so there have to be techniques that will allow you to identify the financial consequences of one versus another. Because it's not always just about the guy inside wants air conditioning or how big the road is you're going to compact, but we can say from a money standpoint, if you're going to be generating revenue with each of these and they have different costs, you have to have some sort of a technique to compare alternatives and identify which one is going to be more profitable. For your company, is it going to be more profitable to buy the small thing that can't do as much, or the big thing that can do more and generates more revenue? So different techniques for comparing alternatives is a big part of what I want to teach you this semester. And another big part of what I want you to learn this semester is the time value of money. Have you ever heard from your parents how cheap gas was in their day? Or how candy bars were a nickel at the soda fountain, or things like that? So, I mean, everybody loves thinking about how cheap things used to be, and I think the notion you probably already recognize is that in the past, money seemed to be more valuable than it is now. You know, a quarter back in the olden days could buy a lot, whereas now a quarter can't buy as much. Another way to put that is that money in the future isn't as valuable as money now. And that's tricky for engineers, because when you're completing a project, you're spending money now, but you're getting your revenue in the future. So you're spending money now when dollars are more valuable, and you're getting paid in the future where dollars are less valuable. And so you have to correct for that effect, that inflationary effect, where the costs are inflating and the value of money is decreasing over time. If you don't understand that time value of money effect, you can get into real trouble by spending money that's more valuable now and receiving the less valuable money in the future. So this illustration is just showing, for instance, which is better, to receive $8,000 in the present, or is it better to receive two equal payments of $4,500 3 and 4 years in the future? Well, 4,500 plus 4,500 is 9,000. So someone who doesn't understand the time value of money would just say, well, automatically the one on the right is better, because 9,000 is more dollars than 8,000. That would be true if we didn't have any inflationary effect, like if there was no interest rate to consider. But if you're given an interest rate, what you can do is you can actually do the calculations and find out these dollars in the future, how much are they worth in today's terms? Like, what's the present equivalent of this amount in the future? So this is a really critical key. And I don't know how many of you have heard of the FE exam, the Fundamentals of Engineering exam. It's one of the tests you have to take if you want to become licensed as an engineer. Problems like this are all over the FE exam. So it's really important to be able to solve time value of money problems. Any questions? Another reason you're taking this class is that ABET requires that engineers are able to solve problems economically. ABET is the organization that accredits your degree. The reason why you could be licensed as an engineer or employed by the federal government or get a loan to earn your degree is because it is an accredited degree. That means that an outside agency comes and periodically audits the quality of the engineering program at Marshall. And so they look into whether we're teaching the right courses and whether we're assessing those courses, and they look at whether students are achieving the learning outcomes that we want them to achieve. And one of the things they look for is they look to see if you're getting the education that would allow you to solve problems and practice the engineering profession in an economical way. And so being able to weigh options in a rational basis, that's kind of another motivation for why this course is required for all students, is that essentially ABET requires that you have certain skills. Okay, I've already given you the overview that we'll start class with announcements and a brief lecture period that may occasionally also include me solving some problems on the board or with Excel. But then more of our time will be devoted to solving in-class exercises. And so that's a handout I give you with some example problems. We'll do one of those today. with the very little time that we've got left, I'm going to have to speed through a few things. But you can work collaboratively on those. Sometimes it'll be hand calculations. Sometimes it'll be Excel work. If you're not very comfortable with Microsoft Excel, that's okay. Because remember, I'm recording these lectures. And so if I work too quickly through anything, you can watch the video later and see exactly where I clicked and what formulas I put in. And so I think everyone at the end of the semester will be a lot more comfortable than they are now, largely because of the practice that we go through with the in-class exercises. And although you can work in groups on the in-class exercise, remember that homework is completed individually. So you'll have enough, you'll have what you need to do the homework. You won't be desperate enough to cheat or copy because you won't need to. I mean, you'll have those in-class exercises done, and the homeworks I think you can knock out pretty easily as a result. Okay, so where do we start? We begin by talking about interest. And interest is a privilege that is paid to the bank because you've borrowed their money for a certain period of time. So the bank gives a borrower a loan, and what the borrower gives back to the bank is that original amount plus a little extra. So from the perspective of the borrower, when you're paying some extra money, what you're paying is interest, and if you wanted to calculate it as a percentage of the original amount, that would be an interest rate. From the perspective of the person who's loaning money, we would call it a rate of return. So the interest rate and rate of return have the same basic formula, but the reason why the phrase is different is it's because the difference is the perspective of who's getting the money and who's giving the money. So in the case, for instance, of an investor loaning money to a corporation, when they get the extra money back, then they're thinking of that in terms of a rate of return rather than the interest that they paid. So interest is a manifestation of the time value of money. It's just an acknowledgement that if I give you valuable dollars now and you're paying me back in the future, you've got to pay me extra. Because remember, those future dollars aren't worth as much as the dollars now. So you wouldn't want to receive the same amount in the future if each one of the dollars wasn't worth as much. So it's a fee that is paid to use money. Another technical way that interest is defined is just the difference between the beginning amount of money that's in an account, for example, a savings account at the beginning of a time period versus the end of the time period. The difference between those amounts in a savings account is because of the interest that has been paid. So the interest amount is the difference between what you owe after the passage of time versus the principal. And if we express it as a percentage, that's the interest rate. So here's the formula for it. The interest rate as a percentage is the interest amount that was accrued in a certain time period divided by the principal, which is the original loan amount, multiplied by 100 to make it a percentage. And we have the same formula for rate of return. Interest amount divided by the original principal amount multiplied by 100. All right, so to get some practice with that, I'm going to hand out the in-class exercise for today. And we're only going to do the problems that are on the front side of the paper. The ones on the back we'll leave until next time. So what I'd like you to do is get out your calculator. Hopefully you've got one today. If not, this one time you can use your cell phone. Generally, I prefer that you use a real calculator rather than your cell phone. And we're just going to practice using this rate of return and interest rate formula. Remember, you don't need to be quiet during this in-class exercise time. It can be pandemonium in here for all I care. In fact, I think it's great. The louder it is, the more you're learning, is how I think about it. So feel free to talk, be relaxed. This is the informal time where you're crunching the numbers and solving problems. But it was all that talking at the start kind of burned through some of our available time. So here's the solution. Let's make sure we're on the same page. So if you borrow $20,000 and they charge 5%, then in 1 year you owe the original $20,000 and also 5% of the original amount as interest. So the total is $21,000. The principal is $20,000. The interest is $1,000. All right, so that's the answer to problem number 1. And remember, this is being recorded. It's doing a screen capture right now. So if you're not able to scribble it all down, you can go to the video and get it later. All right, so problem 2. What's the rate of return if you invest $200,000 and they pay you back $212,000? So the interest amount is $12,000. That's the extra they're giving after a year. And so as a percentage, to calculate the rate of return, it's the interest amount of $12,000 divided by the principal, which is the original amount that was invested. So that's a 6% rate of return. All right, problem 3. Now I'm sure you probably would have been able to figure this out if you'd had more time, but since you don't, let me just give you the broad strokes of how this one works. Today, Peter has 55,000 Icelandic krona in an account that earns 3% interest. So what was the value a year ago in United Arab Emirates dirhams if the exchange rate is 35 krona per dirham? Okay. So the first thing we have to do is find out, these krona that are in Peter's account, what's the equivalent value in dirhams? So we do the currency conversion and find out that today Peter has 1564 dirhams. Now, how much was that a year ago? So the amount that you have now is the initial amount plus the interest that was earned during the last year. And so what you have now was last year's amount plus 1 year of interest. And so the way to set this up algebraically is to say that these 1564 dirhams that's there now is the initial amount plus 3% of the initial amount. So you can't just divide by 0.97. Excuse me, you can't just multiply by 0.97. It will be slightly off if you do it that way. So the way to do it is just to recognize that the amount now is 1.03 times 1 year ago's amount. So algebraically we can solve that the value in the account a year ago was 1518 dirhams. All right, it's 12:50. We're out of time. I never want to keep you late. So let me just quickly jump up here to the announcements and remind you that what you should do is get a binder to put all these papers in. If you haven't already, get the book, and you can take a look at the homework assignment, because even just what we did just now, I think will get you through the first few problems on the homework assignment. All right. Have a good day. I'll see you on Wednesday.